Nuclear reactor, it is a device which is used to produce electric power, and nuclear fission is the reaction which is used to produce a large amount of energy, and that energy is converted into electric power in this device nuclear reactor. A controlled chain reaction is undertaken here in this reactor so that we can convert the energy produced into electric power. The important parts of this particular reactor is that first we will be having fuel rods, then we are having a cooling system and a control rods. That is how it is designed. The fuel which is used is any fissile material, any radioactive material which can undergo fission process like uranium, thorium and plutonium. They are used in the form of cylindrical rod as shown in the figure. These are uranium rods which are used as fuel in the reactor. Next, there is a moderator which is also used in the reactor. The purpose of moderator is to slow down the fast moving neutrons. See, in the fission process, nearly 2 to 3 neutrons are emitted. These neutrons are moving with very high velocity. If they are continuing like that, they may not be captured by another uranium nucleus. The fission process may not continue if that is so. So, what we need to do is these fast moving neutrons should be slowed down to thermal energies about 2 million electron volts. To that level these neutrons must be slowed down. Slowing down of neutrons can be done using moderator. Heavy water, graphite, all these can be used as moderators. When a fast moving neutron passes through this heavy water, it collides with the molecules of heavy water and slows down. So, by the time it emerges out of heavy water, that is moderator, the neutron is slowed down to thermal energies so that it can be easily captured by another uranium nucleus, and so that the fission process continues. That is the purpose of moderator in the nuclear reactor. Generally, heavy water or graphite are used as moderators. Next, we are having a cooling system. In the nuclear reactor, in the core of the reactor, enormous energy is released, and that is in the form of heat. It means that the temperature of the reactor will be very high. We have to have some system wherein the temperature of the reactor maintained at a lower level, at a constant level. That purpose is done by a cooling system. Molten metals or water are used for the purpose. This cooling system is continuously run throughout the core of the reactor so that it absorbs the heat, excess heat from the core of the reactor. That is the purpose of the cooling system. Next, we are having control rods. The purpose of these control rods is to control the chain reaction. See, in fission process 3 neutrons are emitted, and these 3 neutrons may interact with 3 more nuclei producing 9 neutrons. If the chain reaction is continued like that, the entire fissile material, that is uranium or plutonium, whatever you are using as fissile material, radioactive material, that may disintegrate all of a sudden with a release of large energy at a short interval of time. That becomes a big explosion. To avoid that, what we need to do is we need to control the number of neutrons that are emitted. That is, neutron multiplication factor should be made equal to 1. It should be maintained at a constant value. That job is done by control rods. There are good absorbers of neutrons. Best example is cadmium. Cadmium is capable of absorbing neutrons. So, these control rods are arranged in such a way that they can be pushed inside the reactor, or they can be moved outside also, depending on your requirement. Suppose if these rods are moved inside the reactors, they will absorb more and more neutrons, and the chain reaction process is slowed down. On the other hand, if the control rods are moved outside, then more and more neutrons are emitted. Chain reaction will continue producing more and more energy. So, depending on your requirement of the energy or requirement of electric power, the control rods can control the number of neutrons, thereby controlling the chain reaction in the reactor. That's the purpose of control rods. Now coming to the generation of electric power, you can see what happens is within the core of the reactor, these fuel rods, uranium rods, they will undergo fission process and emit energy. So the temperature of this core will start increasing. At that time, the cooling system or molten metal or water is sent into the core of the reactor, and the excess heat that is absorbed within the core of the reactor is it is absorbed by the coolant. It becomes very hot, and that hot liquid is sent into a heat exchanger. This is known as heat exchanger, which consists of water. Now by absorbing the heat from the cooling system, that is hot liquid, the water evaporates and the steam is produced, and that steam is used to run a turbine, a conventional turbine, which produces electric power. So as long as the energy is released in the core of the system, the cooling system absorbs the heat from the core of the reactor, it becomes very hot, and that hot liquid is sent into heat exchanger. Here heat is exchanged from the hot liquid to the water. Water gets the temperature of the water becomes very high, and it becomes it is converted into steam. That steam is used to run a turbine, and you can produce electric power continuously. That is how a nuclear reactor can be used to produce electric power.